In our first two videos, we have introduced the National Research Data Infrastructure, NFDI, and the PUNCH4NFDI consortium, as well as some basics of punch science, the combined efforts in particle physics, astroparticle physics, astronomy, hadron, and nuclear physics. We have also discussed the amounts and rates of data produced by the punch facilities and some of the challenges in big data and open data and in the realization of the fair data principles. Today, we want to get a little more technical and give you a small impression of our data management model and of the activities that the PUNCH4NFDI consortium will undertake in order to enable punch scientists to collect, digest, and scientifically exploit their data also in the future. To accomplish this, PUNCH4NFDI strives to become one of the driving forces for a fair data management infrastructure in Germany, an infrastructure in which the valuable data of our research are fair, findable, accessible, interoperable, and reusable. An important point is that the term data is a very broad one. Data come in very different shapes, and data have very different uses. Let's have a look at a little analogy. Let's compare a scientific insight to a beautiful sandwich. It's a long way to a full sandwich. First, you have to sow the grain, you have to wait for the grain to grow, you have to harvest the grain, you have to flail and grind it. With the resulting flour, you can finally bake bread, and the bread can then be garnished to become a sandwich. Each of the steps, each transformation on the way from the seed to the sandwich requires a lot of work and significant expert knowledge. Similarly, it's a long way to a new scientific insight. First, of course, you have to design and build an experiment. This experiment will deliver data, raw data as they are usually called. These raw data are typically not much use to anybody except maybe the scientists that build the experiment. Raw data need to be corrected and calibrated, and they have to be garnished with explanations, that is, with metadata. That leads to what sometimes is called reconstructed data. These reconstructed data might then be compared to models, or they might be treated statistically before one can arrive at a new discovery, a new firm conclusion, a new scientific insight. Again, each step in the chain requires a lot of expertise and a lot of work. Now, in sandwich making, the complexity of the problem and the sheer amount of sandwiches to be made for all of mankind has led, many hundred years ago, from a subsistence economy to a very clear division of labor. Not everybody is making their own sandwiches anymore. Instead, we have specialists for each of the transformations. We have farmers who sow and grow the grain, we have the miller who grinds the grain, we have the baker, and finally we have shops that turn bread and other ingredients into sandwiches. And many of the steps are done with advanced machinery. What is the situation in science? How has the transformation process of data changed over time, say from the times of the famous Millikan experiment in the early 20th century to the huge experiments of particle physics or astronomy today? As it turns out, data economy is very often still a subsistence economy. Typically, a single scientist in a given field of science creates some data. These data often sit only on his or her computer. And from there, the data are refined, selected, analyzed, transformed, and finally published. All by the one scientist, maybe a PhD student, or at most by his or her team, say a university group. The same happens to another data set, retrieved by a different researcher or group of researchers. The relevant data are stored locally and transformed and published by the same person. In short, very different persons perform very similar tasks, each for him or herself, each having access to their local data only, and probably fighting the same technical problems in the various transformation steps of their data. Problems of data storage, of access to data, of finding compute resources, of data analysis methods and tools, and numerous others. That does not seem very efficient, and it is certainly not appropriate for the big data challenges that lie ahead in many branches of science. Like the division of labor we have seen in the preparation of a sandwich, we also have to turn to a division of labor when it comes to data management and data treatment. A new data management model is required, one where similar tasks are bundled across scientists, across data sets, maybe even across topics and fields of science. A new model of data management and scientific computing that is efficient, flexible, and very important, scalable. Scalable to larger and larger data volumes, to more and more involved scientists, to more and more transformations that we want to apply to the data, and to more and more questions we want to address with the multitude of data that are around. Finally, the model also needs to be able to allow for an easy combination of different data sets. All these requirements are satisfied in a layer model that is already, to some extent, reality in the Punch Sciences, a leader in big data and open data, with plenty of experience in making very large data sets available to literally thousands of scientists. The layer model bundles the vital functionalities of data management, from the data sources that are bundled in a transparent federated data lake, over the storage and compute resources, to the largely cloud-based data transformations and analysis and publication steps. The full implementation of this layer model over all branches, even of the Punch Sciences alone, is still a vision and requires a lot of work. This is where PUNCH4NFDI comes in. We have defined distinct task areas that address the necessary working steps towards the full implementation of the layer model, benefiting Punch Science and the entire NFDI. These task areas are concerned with the storage compute access technology to large and distributed data sets on federated infrastructures, with data transformations and the necessary algorithms, or with the relevant training and education measures needed to bring scientists from the NFDI up to speed in data management issues. But what is the use of the entire endeavor for the individual scientist and for the scientific process? In which way does this serve the implementation of the FAIR data principles? The answer to this is the Punch Science Data Platform. The Science Data Platform will either directly contain or connect to datasets from all corners of our community. That alone, of course, would not be very useful if scientists couldn't find and access the data based on the relevant metadata and on their access rights, and if they couldn't interoperate with the data in ways described again in the relevant metadata information that contains, for example, provenance information and information on workflows for these data. But the platform does not only contain data and metadata. It contains a full scientific knowledge fabric, woven of data, simulation, computer codes, and statistical tools needed to understand the data, and of analysis workflows and scientific articles describing the transformation and analysis steps leading to these data. Based on this interconnected knowledge, the data on the Punch Science Data Platform are easy to access, easy to understand, easy to integrate into new projects. The data can be reused in the scientific process. In short, PUNCH4NFDI and the Science Data Platform keep the data alive. Now, that sounds pretty simple and obvious, but of course the necessary machinery in the back is very involved and quite ambitious. But as probably has become clear, the PUNCH4NFDI consortium and the Punch community at large are quite used to thinking big, so we have set about and worked out a very detailed work program for the next few years. A program that we are going to tackle with all of our many strong partners. As of today, November 2020, PUNCH4NFDI is in the evaluation phase. If approved, we will get to work immediately to solve the computing and data management challenges of the scientific experiments of the future. And we will make data access and usage efficient and fair for every scientist and every citizen scientist, maybe also for you. If you would like to find out more about PUNCH4NFDI or our research data management plans, then visit us at our website or follow us on Twitter.